So we're going to just go through this summary. So it says graphing rational functions can be tricky, but not if we carefully follow the same procedure each time. The two major things we're looking for are the intercepts and the asymptotes. And then if we want to find more points, all we need to do is plug in x values, right? So if I want to flesh out my graph, all I have to do is just, plug in a couple more x values. That gives me a couple more coordinates. And it says there's a couple of things to remember. They're always functions, so they will always have to pass the vertical line test. So you'll never see your function looking like that, right? Because that will fail the vertical line test. And graphs are always going to hug your asymptotes. So if these are your asymptotes, you're always going to move towards your asymptotes like an elbow curve. And it says we've already spent time finding the intercepts. Here's just what I reviewed for you on the board. Plug in 0 or set the numerator equal to 0, finding the intercepts. So here we're going to talk about finding vertical and horizontal asymptotes, which is also the same as what your homework is having you do tonight. Find the domain of the function. So it says to find the vertical asymptotes, set the denominator equal to 0. What is going to be a very bad value for x? It's what is going to make the denominator 0. So in this first function, what's my answer? -3 is a very bad number for this function. So I write my vertical asymptote x equals -3, and I write my domain x can never equal -3. So that's all that you need to do on like the 9 problems tonight on the homework. Where is the denominator going to be 0? All right, and you might encounter a problem that you need to do some factoring. So here is my denominator. So where will x squared minus 2x plus 1 equal 0? So you need to be able to factor the quadratic to get your solution. How does this guy factor? So what are the factors of 1 that add up to -2? It's actually a perfect square trinomial. What would it be? Okay, yes. X minus 1, x minus 1. So where is that going to be undefined when x is +1, right? So my vertical asymptote is x equals 1, and my domain restriction is that x can never equal 1. So we already looked at the numerator when we looked at intercepts. So now we're just looking at the denominator. So it's like tunnel vision. For the y-intercept, you plug in 0. Then you look at just the numerator, and now we're looking at just the denominator. So it's 4 steps, and if you do them in the same order every time, I think you're less likely to get confused. All right. So I'd actually like you to practice that skill. So skip ahead to this page that has 8 different problems on the front and back. Can you just practice finding the vertical asymptote 8 times to let that sink in before we confuse you with the horizontal and slant asymptotes? So skip ahead a page. There's 8 different problems. So on each one, your job is to take the denominator, set it equal to 0, and solve for x. So when will x minus 9 equal 0? When x is +9. So I'm looking for that equation for each of these 8 problems. Some of them will have more than one asymptote. Does anyone have questions? So I'm going to have you unpause. All right, so here, where will x squared minus 9 be 0? So you should factor using difference of squares. And x is either 3 or -3. So I'd have 2 vertical asymptotes on that one. This one would just be at x equals 8, right? 8 will make that denominator 0. So if it's on your homework, x cannot equal 8 would be the domain restriction. Let's see, on this one, where will x cubed minus 2x squared equal 0? So this is a factoring problem. Factor out GCF. So you'll have x squared pulled out and then x minus 2 left inside. So x is either 0 or positive 2 would be your two vertical asymptotes. See how it's just still practicing those factoring skills? You cannot find the vertical asymptotes without being able to factor. You're just not going to be able to get the answers. All right, this page, let's see. Is x squared plus 4 factorable? No, right? It's prime. Can I ever plug something in that will make the denominator 0? Like if I try to plug in negative 2, I end up with 8. If I plug in 0, I end up with 4. So there's actually no vertical asymptote for this one. Just like sometimes there's no y-intercept or there's no x-intercept. What'd you get for n of x? What makes this undefined? Did anyone get it? What will make 2x squared 0? 0. So my answer is x equals 0. All right, what about the next one? Your eye should just be seeing it now, I hope. What makes the denominator undefined? Negative 1. So x equals negative 1 is your vertical asymptote. And then the last one is just 0 again, right? X equals 0. So you have to train your eye to just look at one thing at a time so it's not too overwhelming. So we've done, plugging in 0, then we just looked at the numerator, now we're just looking at the denominator. All right, so the fourth and final part, I say there's 4 parts. This last part is actually a 3-part rule because there's 3 different things that could happen. So it says to find the horizontal or slant asymptote, I just went back a page, you need to look at the highest power of x in the numerator and the highest power of x in the denominator. Basically the degree of the polynomial. That's why we had to learn about polynomials. All right, so 3 different things are going to happen. So if the denominator wins, so see how this is 1 over x? The denominator wins in a fist fight, right? Because the degree is higher in the denominator. It says the horizontal asymptote is always y equals 0 because the denominator is going to blow up and become really big. And what is 1 divided by a really big number? 1 divided by a really big number is 0. So y is always going to be 0. All right, now in the fist fight, the numerator and the denominator are fighting, and you look at the degree. So in this case, the degree of the numerator is 1, x to the first, and the degree of the denominator is 1, x to the first, x to the first. They tie in the battle. So to figure out the asymptote, you peel off the coefficients of the 2 terms. So y equals 2/3 is the asymptote. Because if you plug a really big number in, like 1,000,000, you get 2,000,005, and you get 3,000,000 minus 2. This 5 and negative 2 are pretty insignificant. 2,000,000 divided by 3,000,000 reduces to 2/3. So you want to think about what's happening when you plug in really big values for x. This one approaches 0. This one approaches 2/3. Because it's what is the end of the graph going to approach. All right, and then the last thing that could happen is the numerator wins the battle. And if the numerator wins the battle, x squared over x to the first, this is why we had to learn division. So you have to do slant asymptote division. It's the only time that division is possible, so that one should be easy to remember. So we're going to actually divide x minus 3 into our dividend. And this is why we had to learn division last week. So 3 things can happen. The denominator blows up, so it's y equals 0. They tie, and you strip the coefficient. or the numerator wins and you do division. So every single rational function will have one of these three outcomes to determine your fourth and final step. All right, so let's review how to do division. You put x squared in the first box, right? You've got your divisor on the outside of the box. And so in your quotient, this is going to be your asymptote up here, would go just x, right? X times x is x squared. X times -3 is -3x. And you have to force these two boxes to result in this positive 2x. So what do I need up here? What? Minus 3x will give you 2x. Do 5x. Thank you. All right, if a 5x is here, what goes on the outside? Plus 5. So I don't really care about the rest, but let's just practice our division. I get -15 in the bottom box. So what's my remainder? I need these two to get me to 7. So it would have to be what? Positive 22? So the remainder is 22. The asymptote is the line y equals x plus 5, right? You start at 5 on the y-axis, up 1 over 1. So that's the equation of a line. This is a horizontal line, and this is a horizontal line. Y equals 0, y equals 2/3, y equals mx plus b is a slant asymptote. So there's the summary about numerator, denominator, but I think I kind of gave you the summary up here. The denominator wins, y equals 0, they tie, you peel the coefficients, numerator wins, you do division. So that is what you're going to try to practice 8 times. See if we can solidify how to find these asymptotes. I'll do the first one with you. Actually, you know what an easier way to do this is? You've got 8 different examples, right, on the next page. What I would do first is I would skim every example looking for this to happen. The denominator wins. So skim through all 8 of the functions and look where the denominator has a bigger degree. So not in the first example, because they're both linear functions, right? X, x. But what about the second function, right? The denominator wins. X squared is bigger than a linear function. So in this case, the denominator wins. So over here, I can just write y equals 0 is my horizontal asymptote. So what I would do is I would skim through the remaining 8 problems, look for any y equals 0s right off the bat. Then go to the second thing where you have to strip the coefficients because they tie, and then you'll have division left for last. Okay, so I'm just going to write in, this one should have been y equals 0, the 1 over x. This one should have been y equals 0, because you had 2x squared in the denominator. Let's see, on the front page, we already did g of x, so the other one is this one, y equals 0, j of x. So now you're going to look through and look for where the numerator and denominator are tied in degree, and strip the coefficients. And find where they're equal. So in f of x, they're equal, right? Linear function, linear function. So when you strip the coefficients, you have 1x over 1x. So y equals 1, because 1 million or billion divided by another 1 million or billion will always equal itself. So your horizontal asymptote should have been 1. This example, we're going to have to go back and do division later, right? Because x squared is in the numerator, x is in the denominator. So I got to go back and do division. And what about on this page? Let's see. These are equal. X squared over x squared. You only look at the leading term because that determines your degree, and you strip the coefficients. So 2x squared over 1x squared, y equals 2 is my horizontal asymptote. And that can be tricky because some students want to add in the weight of this like 4x or this constant. All you care about is the degree. If the degree is tied, all you do is strip the coefficient of the leading term only. All right, and then it looks like on Q of x, you're going to have to go back and do division. So try the 2 division problems on your own, see if you can produce the asymptote. All right, and then we're going to see if we can do a graph all together. So I put x minus 8 down the side, right? I'm trying to get x squared, so I put x squared in the box. Then I put x outside the box, and I get negative 8x down in the bottom. I'm trying to get to positive 6x, so I need to put 14 x's here so that when I subtract the 8x, I get 6x. So plus 14 is the end of my asymptote. And then if I want to find the remainder, I have to do 14 times negative 8 is negative 112. And I'm trying to get to positive 5, so I need a remainder of 117. Is that what you got? It doesn't matter. As long as you got y equals x plus 14, you have the asymptote correct. All right, so maybe some of you are feeling good about your division skills and some of you need more practice. There's more practice when you have to find the asymptotes on Tuesday night's homework. So Monday night is just finding domain, which is basically your vertical asymptotes. And then Tuesday night's homework is practicing the other asymptotes. All right, so this one, we need to take x plus 1 down the side, and we're trying to get 3x squared inside the box. So I put 3x on top, right? 3x squared. So I get 3 x's in the bottom of the box. I'm trying to get to negative 2x, so I have to subtract 5x. So your asymptote should have been 3x minus 5. If you wanted to find the remainder, it would be what, 10? Remainder of 10. So y equals 3x minus 5. Did some of you get that as your asymptote? Or if nobody did I do something wrong? A couple of you got that? All right. So let's do one example of kind of what it's going to mean to put all of this together. So I'm going to be giving you a function just like this on your quiz on Thursday. When you have your quiz, you're going to have to find these pieces and then sketch the graph. So I always go in the same order every time. So how do I find my y-intercept? I plug in 0 for everything on the right-hand side, all the x's. So what would I get? 0 comma what? Plug in 0. What's 6 divided by 3? All right, so my y-intercept is 0 comma 2. And I go ahead and I just plot that right away on my axis because I don't want to forget to plot something. All right, so step number 2, after you plug in 0 for x, you find your x-intercept. And the shortcut for x-intercepts was thinking about your numerator by itself. Can the numerator ever equal 0? No. So in this case, there happens to be no x-intercept, and that is okay. Now, I look at the denominator by itself, and I think about what will make the denominator 0. So what's my bad value? Negative 3. So I can record my domain, x cannot be negative 3, and my vertical asymptote as x equals negative 3. And I'm going to plot that on my graph. So that is a vertical dotted line at x equals negative 3. My graph cannot touch that vertical line. So I've done 3 out of the 4 steps. My 2 intercepts and my vertical asymptote. I'm skipping the range until I do my last piece here. All right, so now I compare the degree of the numerator with the degree of the denominator and who wins in a fight. The big old denominator, because it is a linear function And this doesn't have any x, so this is a constant function. A linear function, if I plug in a big number, is going to win. What is the asymptote if the denominator wins? It's always what? Y equals 0, right? So that is my other asymptote. I kind of expected that because I didn't have any x-intercepts, right? So it kind of makes sense that it's kind of hard to see, but y equals 0 is your other asymptote. If you don't have any x-intercepts, it's probably a good clue. All right, so now remember, hug asymptotes pass the vertical line test. So if there is a elbow in this region, because I can see my intercept, the elbow is going to look like that. So the elbow is going to get close to the asymptotes and go through the intercept. So there's going to be one other elbow. The elbow could either be over here or down below the axis, but it cannot be over here because that would be directly underneath that part of the graph. So to figure out which region your elbow is in, we have to plug in a value for x and get another coordinate. So I would plug in -4 because that's to the left of the asymptote and see what you get in this function. So if we plug in -4, 6 divided by -4 plus 3 is how much? Just -6, because I get -1 in the denominator, and so I get 6 over -1. So I know that the point -4, -6 lies on my graph. So -4, 1, 2, 3, 4, 5, 6. So I know that the elbow goes through that bottom region of the graph. So all you need is one point, and then you can assume that the elbow hugs the asymptotes. But you have to find the point to know if it's going to be up here, because sometimes you'll have a volcano graph. Most of the time they're going to be opposite each other, but some of the time you really will have this volcano where you've got two going up. So you do need to actually check your coordinate. All right, what's the range of this function? As I skim it kind of like up and down, what is my only y value that I can't have? I can't have 0, right? So my range is y can never be 0. And then they threw in at the bottom here a limit analysis. So this is just an introduction to some notation you'll see this year. This says, as x approaches infinity, what is the function doing? So it's asking you about this arrow right here. As x is going to the right, what is your function approaching for a y value? Where's that arrow getting really close to? What value for y? It's getting close to 0, isn't it? All right, so that's my limit analysis. The function is approaching 0. Now it's asking you to find the other arrow when x is going to -infinity, which is over here. What's this arrow getting really close to? It's also getting closer to 0, isn't it? Right? So those two ends of the graph are approaching 0. And then it wants you to analyze the graph right at the asymptote. See how the asymptote is -3? Do you see this tiny little plus sign? That just means on the positive side, the right. And this little tiny negative sign means on the left side. So this first one is asking you about this arrow, -3, and then the plus sign is asking you, where is that shooting towards? So that y value is shooting towards positive infinity. So f of x will approach positive infinity. And then the other part says, as x approaches -3 from the left-hand side, now it's talking about this last arrow. Where is that arrow shooting towards? It's going towards -infinity on the y-axis. So this, we're going to get some practice, this unit. It's not going to be highly assessed, this unit, but this is limit. This is the limit language that you'll see in our last unit of the year. All right.